All right, welcome everybody. Thanks for coming to, I don't know if this is the last session, but it feels like it is late in the day and maybe it should be the last session. Thanks for coming to our session instead of going to happy hour. It is kind of that time, right? Everybody's probably had a long day absorbing a lot of information, so I think this is gonna be a very interesting session. Not everybody knows what FINRA does. Maybe you do, then that's why you're here. I'm curious though, how many of you are using Fargate today? Show of hands. All right, decent mix, over half. How many know who FINRA is? Show of hands. All right, a little less, maybe a third. Right. So that's what you're dealing with, Corby. So I'm Mike Isbitsky, Director of Cybersecurity Strategy with Sysdig.
Corby Shaner, Lead Security Engineer for FINRA.
A few stats to start the presentation. If you've seen Sysdig, we do produce a report on cloud native usage. There's quite a few useful statistics in there. Most of these are actually relevant to Fargate and serverless. The first is, 75% of containers run with high or critical vulnerabilities. This is interesting, right? Container images, where you source them from, particularly public repositories or registries, can have quite a few latent CVEs, right? Maybe they age out over time and new CVEs are uncovered. So it's not uncommon to find container images with latent vulnerabilities. There's also interesting problems that start to emerge with nested dependencies or images that reference other images, right? So it's not always as clear-cut as it seems, and Corby, I think, we'll touch on that a little bit later. 50% of containers have no limits defined, right? When you think about resource constraints, how much CPU should the container be allowed to have? How much disk space or memory, right? These things are important, certainly for availability. Your cloud consumption bill can kind of get out of hand very quickly, right? If you're not defining workloads in the right way. And Fargate's interesting, right? Some things are taken out of your hand, particularly things like root, right? Containers really shouldn't be running as root as a security best practice, but in Fargate, that's technically not even possible. But there are some things you do have to define within Fargate to run a workload, which, like I said, does include resource constraints. So you could have workloads that are just consuming too much compute. So yeah, I'd highly encourage you to check out that report if you haven't seen it. There's actually useful stats for kind of DevOps strategies or DevOps practices, as well as security. It's a mixture of both, right? There's certainly a convergence when you get into kind of DevOps. Agenda for today, we're going to do a very brief primer of security challenges that occur within serverless technologies, specifically Fargate. We're not going to be talking about something like Lambda today, so it is specifically Fargate. We're going to talk through Falco, Sysdig's open source project that helps with threat detection and response in all types of cloud and container environments. And then Corby is going to actually give us, I think, some of the juiciest stuff today, which is FINRA itself and how FINRA works with Fargate workloads and secures them. All right, what is AWS Fargate? I don't know if AWS has done sessions on this. I would imagine so. If not, there's very extensive documentation, as there is with most AWS services. It's not entirely new, right? Fargate, I think it's about 3 years old at this point, 3 or 4 years. There's different ways you can consume Fargate. It is designed for container orchestration platforms. So there's 2 flavors. You can do ECS or EKS with Fargate. It's kind of an alternative to EC2. It allows you to deploy and manage applications as opposed to infrastructure, right? And this is kind of a pretty big shift from how most IT practitioners think of how you operate workloads or provision things, right? You don't necessarily have to worry about setting up bare metal or virtual servers or infrastructure to support that. It's kind of abstracted from you. AWS does a very good job of spinning up exactly the compute that you need and absolving you from that. That's a lot of benefits to IT teams, right? When you think about kind of the traditional IaaS operating model with EC2, there's a lot of time spent defining VMs and the associated images and making sure you have the right resources, and then you can hit a bottleneck with not enough compute, right? So it's a lot of IT burden. And I believe this is actually another thing that Corby's going to touch on for the FINRA section. And only pay for what you use, right? That's kind of always been the promise of cloud, certainly AWS. You're not going to be paying to put servers in your data center environment. You're consuming exactly what you need. That kind of worked with IaaS and EC2, but we needed more, right? We wanted precisely just what we needed to run that specific application or workload. The reality with something like Fargate, the abstraction is both a blessing and a curse, right? So we've removed that control of the infrastructure, but that also presents some security challenges. Specifically, how do you maintain visibility in the environment? You don't necessarily have deep insight into the control plane for the infrastructure, but things are also much more ephemeral. Workloads are going to be spinning up and terminating much more quickly than you've been used to with something like EC2. How do you detect and alert quickly on vulnerabilities and threats, right? So you need to be checking constantly for CVE IDs in your container images, in your build pipelines, in your registries, in delivery, right, as you're spinning things up, but then also continuously in runtime, because new vulnerabilities can be discovered or new threats emerge in your workload, right? Even if it is a very short-lived workload. You also need to capture detailed records to support digital forensics and incident response, but this is also kind of a big regulatory burden. You need very extensive audit trails for, maybe there's a legal investigation after the fact. So threats can manifest in different ways. We often think of them in security context, but there's a lot of risks that organizations face, so you need good auditing capability, logging and retention. Three categories of container-specific threats or issues. The first, as I mentioned, is container image corruption, if you will. It could be an unauthorized user. In some cases, it might actually be a legitimately authorized user that embeds something in a container image that really shouldn't be there. It could be misconfiguration. Maybe they're not well-trained in security practices, so they're adding something they shouldn't. So a lot of organizations spend time focusing on making sure the container images are clean, all right? Practice good hygiene for the container images coming in, bless those, that's my sanctioned registry, and you should only source from there. The problem though is, as engineers, we often, we don't build everything from scratch, right? We source other open source componentry and images. Some of those things might have latent vulnerabilities or nested or transitive dependencies. They're very hard to analyze that. Specifically just in build time, you might have to execute and observe what happens. Control plane misconfigurations. You actually heard some of this in the keynote this morning. But control plane, there's multiple control planes when you think about cloud-hosted container platforms, right? You have the container orchestration platform itself, which is a control plane. And then you also have the cloud configuration control plane. So, there's multiple spots that things can be misconfigured. It does get incredibly complex when you get into container architectures. Most organizations have multiple, as you'll see with FINRA today. And there's almost always a mix of kind of legacy or traditional or monoliths, however you want to refer to it, or brownfield and greenfield, right? Not every organization is born in the cloud, so they're wrestling with traditional architectures as well. And overly permissive access controls. This also came up in the keynote, right? We heard about you should be doing least privilege. Well, as security practitioners, that's kind of a given, right? We've all been trained in that kind of way of thinking. Reality is something much different. It is very hard to do that in practice. You're talking about mix of user identities, machine identities. Things are highly automated, right? You're not talking about 100 employees or 1,000 employees or maybe 100,000 employees. You're talking about hundreds of thousands of machine identities and resources communicating to each other, and those things might be very short-lived, right? So it is a very difficult problem to solve at scale. The other thing to remember is that containers and serverless, they can't be secured in the same way as server endpoints. I see this pretty commonly that organizations will attempt to move their EPP or endpoint protection and endpoint detection and response technologies to clouds. It can have some success if you start with things like IaaS, but as you move into container as a service or platform as a service, you quickly hit a wall. The technologies just aren't built for this kind of new cloud native technology world. All right, so the Falco piece as promised. What is Falco? So as I mentioned, it's something that Sysdig created and then open sourced, contributed to the CNCF in, I believe it was 2016. But it works by instrumenting Linux system calls, and then those system calls we can use to secure workloads. Parsing Linux system calls in runtime. There's a few ways you're going to see in a moment here with an architectural kind of overview that is a bit of an eye chart. But it taps into that stream of system calls to analyze all of the telemetry, and then you can make informed decisions about how should I respond to this particular event. Is it even anomalous or potentially malicious, right? And then there's a very robust rules engine around that. And regardless of what anybody tells you, we need rules, right? Most technologies operate by sets of policies or rules. So that's Falco, right? Kind of in a nutshell. What does it look like architecturally? Well, there's a few ways that we instrument those Linux system calls. It's either kernel, which is kind of a difficulty in Fargate, which we're going to touch on in a minute. But also things like eBPF, extended Berkeley packet filter, is another way to instrument Linux-based workloads. There's also other forms of telemetry, right? When you think about most architectures, we have Kubernetes in many cases, which you see by the kind of navigation or Spinnaker logo there. And then cloud metadata logs, right? Your cloud trails, for instance. All of those things are very rich sources of information to kind of inform you about what might be going on in your entire environment, as well as that specific workload. And Falco, as I said, works based on rules. Those rules are applied to the stream, and you could kind of determine, do I want to alert only on this event? Do I want to terminate the workload? Do I want to trigger a workflow in my SOAR platform, or trigger something within my SIEM like Splunk? There's quite a few scenarios, right? Every organization's kind of unique in their security workflows that they use for their incident response. So these, as you kind of move to the right side of the chart here, you can see there's different mediums or mechanisms to relay that information and take action on it. So the Fargate piece, right? I mentioned that Fargate's tricky because it abstracts away a lot of the infrastructure. Well, in reality, that means that you kind of lose access to the kernel, right? So this presents a lot of problems for security teams that are used to having access to the kernel to control things and then also get visibility. AWS actually implemented a way to instrument Fargate workloads via the sysptrace capability, which you'll see here. And Sysdig was working with AWS at that time to make sure that our customers and prospects want those things, right? We need the ability to instrument Fargate workloads. There's a lot of adoption of it going on. This would be a really great feature to have. So that's how Sysdig instruments Fargate workloads. Not an easy problem to solve, right? It looks kind of simple just looking at the screenshots. And you can certainly take a look at the articles. There's some cool stuff from our founder, Loris Dejani. All right, so how does the Fargate capability specifically work? There's kind of two architectural or workflow elements to this. The first is image scanning, right? We talked about the images can be sources of vulnerabilities or misconfigurations, so we have to make sure we're checking those things constantly, right? So in Fargate, how does that work? I want to spin up a Fargate task that's going to be based on a container image that's specified, the base image for that Fargate workload. Sysdig taps into the stream, which is actually Amazon Event Bridge that's doing that, registers the event, and then we can trigger a container image scan within your cloud environment, which is really appealing to organizations that want to do things on-prem, right? Or there's that privacy concern about sending things to SaaS-based services or external vendor platforms. The scanning occurs within your environment. It's inline image scanning. So trigger a task within something like code build to scan that image, and only the metadata goes out to Sysdig's platform to aggregate the results, right? So you can report on those things. But anything in the image like keys or sensitive code, that's intellectual property for your organization, is not going to be leaving your environment. The second piece of this is really the runtime detection and response, right? And this is kind of where some of the magic, or more of the magic, happens in that, again, the Fargate workloads are spinning up. They're very ephemeral. We don't have that same kind of kernel integration. But as I mentioned, with that sysptrace integration, you could refer to this as an agent. It's kind of a tricky label, right? Sometimes people hear agent, they think that's very heavyweight. That's not how this is designed, right? It needs to be very lightweight, because when we're talking about serverless architectures, they need to be very performant. And Corby's going to talk about that in the FINRA use case, right? It's really cool stuff with the amount of transactions they're dealing with, right? So an agent can exist, right? You need ways to instrument workloads. It's not necessarily a bad thing, right? Sometimes there's too much leaning towards agent lists. We do still need instrumentation mechanisms for workloads. And the other piece of the Fargate technology, there's also a orchestration agent that exists within the environment, and that kind of is responsible for communicating with all of these instrumentation mechanisms within your Fargate workloads that get spun up, and making sure they have the right policies to enforce those Falco rules that I mentioned earlier. And as I said, all of that's kind of open sourced, right? It's based on the open source Falco engine, which is a CNCF project. With that, I'm going to actually hand it over to Corby, because I think this is the good stuff.
Thank you, Michael. So, FINRA, how it secures Fargate workloads. First of all, let's get into what FINRA is, who FINRA is. Our mission is to protect investor protection and market integrity. Basically, we monitor the stock markets and regulate the transactions that are happening. And we do that by detecting and preventing wrongdoing in the US markets. We also have the power to discipline those who violate these regulations. And obviously, that's how we deter them. We've been around for quite a while, I think officially since the 1930s, but we've had various names over those years. So, in brief, we monitor over 630,000 brokers looking for insider trading, abuse, fraud. Basically, if it's traded on the markets, we see it. We were named #1 best place to work in IT by Computer World. And we regulate 3,700 security firms, which is about 99% of the entire US equities market. So this equates to a lot of data. We process up to 550 billion transactions every day. This isn't a hard number. Obviously, it's going to vary a lot depending on the volatility of the market. The more volatility, the more transactions we have to process. We're monitoring 24 different exchanges, and we store approximately 110 petabytes of data. And to process through all that data every day, we're spinning up about 150,000 compute nodes. So why do we want to move to Fargate? Because we have these two legacy architectures. Most of our applications are running behind a standard architecture that most of you have probably seen. Auto-scaling groups of EC2s behind a load balancer for EC2, and for ECS, a standard ECS cluster behind an ALB or NLB. And we wanted to get away from managing host operating systems. There's a bit of security overhead when you have to manage EC2s. And with Fargate, we don't need to do that anymore. So we also have more price options for compute, improved resource utilization, which also reduces our costs. And Fargate seems to be better suited for dynamically sized batch jobs. If we have a volatile market, obviously we're going to have volatile infrastructure. Not really volatile, but dynamic infrastructure that scales up, scales down, and is right-sized for the jobs. And as I said before, we wanted to eliminate the management of EC2 infrastructure. And the other thing about Fargate is auto-scaling seems to be a bit more seamless than EC2 auto-scaling. So now we've got Fargate architectures running behind a very much simplified, on a very much simplified infrastructure. So we have, at any one time, we have several hundred tasks running, batch processing or what have you. So the security concerns we had with Fargate is we can't run security agents in Fargate because most security agents rely on access to the host operating system. We can't do this in Fargate. The other thing is ephemeral compute. It complicates the visibility and forensics. If you have an incident on a Fargate task and that Fargate task terminates, well, you've lost potential evidence. We needed more visibility into what's happening on these tasks. Another thing is application teams. They can use unvetted third-party images without prior approval. I won't say this is a problem at FINRA, but it is a potential risk. And without a security agent running in Fargate, this becomes a problem because we could be opening up security holes. We don't know. We need that visibility. There is no file or network monitoring on Fargate either. And containers, well, containers can't run as root in Fargate because this is not allowed, but they can run with elevated privileges. That could present some problems too. So we needed a solution that covers all these bases. So we decided to go with Sysdig running in Fargate tasks. This provides us the equivalent endpoint and detection and response capabilities for containers as what we have on host operating systems. We can also power runtime anomaly detection out of the box with Falco. As soon as we create a new Sysdig account, as soon as we get a license for Sysdig, right out of the box, you have default detections enabled, such as crypto mining detection, various other anomalies that will be detected. You can also unify monitoring controls across various compute types. Let's say our previous infrastructure on ECS. We also have Sysdig running there, and we can unify the data that we see on ECS with the data we have in Fargate, all on one platform. We can also pull the information from Sysdig and ingest it into a SIEM platform, into a logging platform via Sysdig API calls. So Mike was talking about build time scanning. This is the image scanning feature of Sysdig. We can fail CI/CD deployments if vulnerabilities are discovered in an image. This is via the Sysdig inline image scanner. This is a separate feature from the agent that runs on Fargate tasks. So during runtime, we can alert on Fargate tasks when anomalous activity is found, such as let's say somebody decides they want to do some crypto mining in a Fargate task. Sysdig will detect that, and we have the option to either alert on that or stop the activity altogether. You can stop the activity by killing the process or shutting down the network or various other mitigations. Another thing you can do with runtime is you can monitor and prevent container drift. This is a new feature Sysdig released very recently. This allows us to prevent a container from using a binary that was installed during runtime. Like, let's say somebody decides they want to install Netcat and use that for something. We can have an alert for container drift that detects that and prevents the container from using that binary from that package. That's pretty cool stuff. So by using Sysdig on Fargate, or using Fargate in general, this opens up some I guess, cultural questions, cultural changes within app teams. So security prefers direct host access because most security teams are used to running an agent that runs on top of an operating system. They have access to the kernel. They can see everything that's happening. We can't do this in Fargate. So now security feels uncomfortable. Application teams don't like agents because there's a performance overhead concern. We can all say, oh, this doesn't add very much this doesn't have a very high performance hit. We can say that all day, but are they going to believe it? We don't know. Teams must learn ways to interact with the running workloads. So on EC2 and ECS, you can SSH into an EC2, and you can see exactly what your container is doing. We lose that when we go to Fargate. Yes, AWS does have a way to actually log into a running container on Fargate, but there were some other concerns about that. We decided not to go that route. So we just restricted access to Fargate containers altogether. Sysdig API integrations helped to enable our shift left strategy. From our CI/CD pipelines, we can call the Sysdig APIs and get the status on an image scans results, or we can rescan an image if we want. There are various things we can do with the Sysdig API directly from the CI/CD pipeline. All right.
Yeah, I think that's, well, thanks everybody. That's kind of the material.
Yeah.
But it's like, I actually want to touch on some things because there's a lot here, right? There's a lot here to unpack.
Yeah.
A lot of organizations talk about shift left strategies, but it's really hard to do that, right? You don't have just one CI/CD build pipeline. That is an anomaly in itself, right? Most organizations have multiple. It's kind of a byproduct of what tech stacks they're working with, what infrastructure types, what applications have they built, right? You heard a lot about FINRA's specific use case, which is really interesting, right? Like, I don't think the appreciation for how much data they have to review real time, like, it's huge, right? It's almost like AWS itself, right? There's a lot of data that has to be analyzed real time, and it is to protect American citizens and investors, right? There's a lot of shady things that can happen within brokerages. So the FINRA mission is very interesting in itself. But shift left is really hard to accomplish. I spent a lot of years as an analyst talking to organizations from all verticals and of all sizes. This was a really big problem, right? There's kind of the idea, it's almost like zero trust, right? Or least privilege, threat model, right? Like, we know all these security principles, but reality is something much, much different, right? And most organizations, FINRA is actually pretty unique. They have, I'd say, what is a very mature DevOps approach for this Fargate technology, but most organizations have problems locking down all of their container registries, right? Developers tend to source things from other locations. Infrastructure teams are sourcing things from different locations. It's very hard to get a handle on all of your registries and code repositories. Some organizations refer to those as secure software factories, right? But it's there's also cultural elements or friction, really, right, between development, operations, and security teams. So, Fargate alleviates some of that by virtue of abstracting infrastructure, right? So ideally, the life of an infrastructure and operations person should be easier, right? But we're actually, you create some new challenges, right, in the new environment with the abstractions. And actually, a lot of infrastructure kind of becomes more codified, right? You're working with infrastructure as code, things like CloudFormation in the case of AWS, but you're probably also working with things like Terraform, yet another kind of technology, right, that's going to result in another build pipeline. You start running into things like GitOps, right? How do you automate all of your infrastructure? Things are accelerating or moving through pipelines very fast, right? So looking at it on a slide and conceptualizing, well, this is my build pipeline, it's easy, right? But now you likely have multiple. I'd say it's always 2 or more, but I've seen some pretty crazy numbers. So how do you rationalize all of your policies, all of your governance, all of your auditing capabilities across all those pipelines, and then get kind of unified detection, right? It's kind of a big organizational impact. And I was curious too, not to put you on the spot too much, Corby, but the one about your reasons for moving. Did you guys do like any studies on like how much time was spent managing EC2 infrastructure? Like, I mean, we know that it takes a lot of time, but I'm curious, like, was there a reduction in headcount potentially?
Not really a reduction in headcount, more like an increase in developer satisfaction, really.
Okay.
That they can spend more time developing code and testing it than deploying infrastructure.
Mm-hmm. Yeah, so kind of developer experience, right? It's yet another variable there. But it's interesting, like especially. Oh, we were saying that. Like current market conditions, right? And Corby and I were talking about this earlier. I don't know what he can disclose publicly, but if you think about kind of current market conditions, there's a lot of buying and selling going on right now, right? Because companies are trying to get small edges with short selling or, basically, I don't want to say gaming the market, right? But they're trying to generate profits for their companies, and it's very hard times financially, right? So this issue of headcount and costs is definitely rearing its head, right? So maybe you're running into this with why you're considering Fargate in your organization, but hopefully this material was helpful for like kind of thinking about some of those big rocks of security challenges that can emerge and some potential solutions to help you in that realm. I think we're great on time. I mean, I appreciate everybody staying around. Were there any questions from the audience? Yeah, go ahead. This one here. I will defer you to the blog. It's linked in the slides because it does get very technical and I don't want to butcher it. But yeah, it is pretty cool stuff. And
it is a sidecar. It's interesting how it works. It's a sidecar, but nothing is actually running in the sidecar. There's a volume that's being mounted inside your other container, and that container is running the binary. The question is Sysdig taking the, could you repeat that?
Yeah, is Sysdig providing you as a customer a container image that you then run as a sidecar?
Oh, is Sysdig providing us the image to run as a sidecar? Yes, they are. Yes, so the way the binary works is it's actually kind of a pass-through. It's running as PID1 in your application container, and as PID1, it's able to see all of the system calls. And your actual application will run as a child PID. So everything needs to go through PID1 to get to the kernel.
Yeah, and was that specifically the workload agent or the orchestrator agent? 'Cause there's
That-
kind of two moving pieces to it as well.
That
so.
is the workload agent.
Yeah.
The orchestrator agent, it actually aggregates all of the data from all of the thousands of workload agents. And it'll send that data to Sysdig, to the SaaS platform, through one line of communication. So it's an aggregator, really.
Does that orchestrator agent also sit within your Fargate, or is that just something
That should be within your customer environment. So
Yeah,
similar with the image scanning, right? It's not going external.
Yeah.
I believe there's like region settings also, right? Because you could potentially have performance there. But yeah, the blog entries there, it's definitely extensive. Good question. Thanks for asking.
Yeah. Yes. The question is, when we were evaluating Sysdig on Fargate for image scanning, did we find that the AWS image scanner was not robust enough? I don't recall what the circumstances were, but I know we did. I know we did look at that, and we decided not to use that.
I think at one point it was
It's
based.
obvious.
Yeah, I think at one point it was based on Claire, right? The AWS image scanner. I believe so. Yeah. So I mean, that was pretty common. I used to hear that a lot from organizations. I don't know if AWS still uses that, but I mean, it's kind of like, I would say, a low bar. Like if you need image scanning in your pipeline, you're likely to find something like Claire, and it could work. But you know, there's a lot more things you might want to check in your container images.
The other thing we wanted was something we could integrate in our CI/CD pipeline. If a certain level of vulnerability was discovered during the build, we want to be able to kill that build right then.
Yeah. So I think the question is like, what CI and CD services can you integrate with? I don't have the laundry list. It is pretty extensive though, and there's different, native integrations versus invoking command line or API calls, but it's definitely flexible. I mean, that's kind of what it's architected for. There is other slides that kind of have those rundowns. Yeah, it's interesting too with like build decisions, right? Pass fail. A lot of organizations would ask that as well, right? I want to automate all of my security. Well, the reality is, as you start running even something like an image scanner, right? It's going to uncover, even something basically like Claire, right? It's going to uncover a lot of CVE IDs. So then the next question becomes, well, what's actionable, right? How do I know, is this an actual risk? Like, do I move this thing to production, right? And it's like a lot of organizations get stuck where it's almost like the inverse of vulnerability management. It's not things you're scanning in runtime and then working through a mountain of findings. Now it's, well, I found all these things in my build pipeline, now what do I do, right? And I don't want to stall the build pipeline because now I'm impeding release velocity. So in some ways it's worse, right? Because now you're actually impacting DevOps and likely your organization's digital transformation. So tricky stuff, right? It's like, it starts simple, seems simple, right? Just throw an image scanner at it, but like, what do you do once you find the latent problem? Yep. Good stuff. Any other questions? Good stuff. All right. Thanks, everybody. Thank you.
Thank you.